Where could aliens be hiding on our very own planet Earth? It's a question that has fascinated scientists, conspiracy theorists, and curious minds alike for decades. If extraterrestrial beings have indeed visited our planet, where have they managed to conceal themselves from our prying eyes? Let's embark on a journey through the depths of the oceans, traverse the dark side of the moon, float among the clouds, camouflage in the desert, explore the tallest mountains, and delve into areas riddled with anomalies to uncover the possible hideouts of alien life. Diving deeper into the mysteries of our planet, we explore the vast, uncharted territories of the deep sea. It's a world of extreme conditions, with crushing pressures, frigid temperatures, and total darkness. Yet despite these harsh environments, life has found a way to thrive, adapting in the most astonishing ways. But could there be more to these dark, silent depths than meets the eye? Could extraterrestrial beings find refuge in the secluded sanctuaries of our oceans? The deep sea remains one of the least explored areas on Earth, with scientists estimating that up to 95% of the ocean floor remains unseen by human eyes. This vast hidden expanse provides an ideal location for aliens to hide, away from the prying eyes of humanity. The incredible depths and pressures of the deep sea would pose significant challenges to exploration, ensuring privacy and secrecy for any extraterrestrial activities taking place beneath the waves. Moreover, the deep sea is home to some of the most bizarre and alien-like creatures on Earth. From bioluminescent jellyfish to gigantic squid, these creatures have developed unique adaptations to survive in their extreme environments. This biodiversity could be of particular interest to extraterrestrial beings. Studying these life forms to better understand the limits of biological adaptation, and perhaps even to glean insights for their own survival on other planets. Adding to the allure of the deep sea as a potential alien hideout are the numerous underwater anomalies that have been discovered over the years. Sunken structures, mysterious formations, and unexplained phenomena have all been documented, fueling speculation and conspiracy theories about extraterrestrial involvement. Some believe that these anomalies are evidence of ancient alien civilizations, while others suggest that they could be contemporary bases hidden away from the surface world. Venturing beyond our own planet, we turn our gaze to the moon, Earth's closest celestial neighbor. For centuries, the moon has captivated our imaginations, inspiring myths, legends, and scientific inquiry. But it is the moon's dark side, the side perpetually turned away from Earth, that holds the most intrigue and mystery. Could this hidden hemisphere be a secret refuge for extraterrestrial beings? The dark side of the moon is shrouded in mystery, with its rugged terrain, deep craters, and towering mountains. It provides a stark contrast to the familiar face of the moon that we see from Earth. This hidden landscape offers numerous hiding spots for extraterrestrial beings, away from the scrutiny of telescopes and spacecraft. Furthermore, the moon's lack of atmosphere and harsh conditions would make it an unlikely place for humans to stumble upon an alien hideout. The extreme temperatures, radiation exposure, and lack of breathable air create a natural barrier, deterring human exploration and maintaining the moon's secrecy. Despite its inhospitable conditions, the moon holds a strategic position in our solar system. Its proximity to Earth makes it an ideal location for observing and studying our planet, while its distance provides a level of security and isolation. Extraterrestrial beings could utilize the moon as a base of operations, conducting research, gathering resources, or even using it as a staging ground for further exploration into the depths of space. Adding to the allure of the moon as a potential alien hideaway are the numerous anomalies and unexplained phenomena that have been observed and documented. From strange lights and flashes to irregular structures and formations, these mysteries have fueled speculation and conspiracy theories for decades. Some believe that these anomalies are evidence of extraterrestrial activity, while others suggest that they could be natural occurrences, misunderstood due to our limited knowledge of the lunar environment. Now let's cast our eyes upward, beyond the boundaries of land and sea, and delve into the boundless expanse of the sky. The clouds, with their ever-changing shapes and sizes, provide a mesmerizing and, possibly, an ideal hiding place for extraterrestrial beings. Imagine beings or even entire ships concealed among the clouds, observing us from a safe distance, completely undetected. The idea might sound like something straight out of a science fiction novel, yet when we think about it, the sky is vast and often goes unobserved. Most of us only take a passing glance at the sky, unaware of its potential secrets. Clouds can cover entire cities, and their thickness can make them impenetrable to the human eye. It's within this shroud of mystery that aliens could find the perfect camouflage. Moreover, there are phenomena in the sky that we still don't fully understand, such as ball lightning, strange cloud formations, and unexplained lights. These anomalies have, on numerous occasions, been linked to potential extraterrestrial activity. Could it be that these unexplained phenomena are actually signs of alien life hiding in plain sight? On top of that, there have been countless reports of unidentified flying objects, UFOs, emerging from or disappearing into clouds. These accounts, coming from people from all walks of life, including reputable pilots and astronauts, add an intriguing layer to the theory of extraterrestrial beings using clouds as cover. Turning our attention back to Earth, we find ourselves amidst the vast and arid expanse of the desert. With its extreme temperatures, scarce water supply, and harsh living conditions, the desert might seem like an unlikely place to find extraterrestrial life. However, it is precisely these harsh conditions that could make the desert an ideal hiding spot for aliens. Deserts cover about 1/3 of the Earth's land surface, providing a vast area for potential extraterrestrial activity to go unnoticed. The desolation and lack of human presence in these areas offer a level of seclusion that is hard to find in other habitats. The ever-shifting sands of the desert can conceal anything beneath them in a matter of minutes, making it an excellent location for aliens to hide their bases or technology. These hidden sites could serve as observation posts, research facilities, or even shelters for extraterrestrial beings studying Earth. Additionally, deserts are home to a plethora of mirages and optical illusions caused by the bending of light rays in the hot air. These illusions could serve as a natural form of camouflage for extraterrestrial beings, allowing them to hide in plain sight. Adding to the mystery are the numerous unexplained phenomena and anomalies associated with deserts around the world. From the mysterious moving rocks of Death Valley to the unexplained structures visible in satellite imagery, these have baffled scientists and researchers for decades. Could these phenomena be linked to extraterrestrial activity hidden beneath the sands or disguised as natural features of the landscape? Venturing into the towering realms of the world's mountain ranges, we find landscapes teeming with mystery and seclusion. The rugged terrains and harsh climates of these areas have long deterred human intrusion, making them an intriguing prospect for potential extraterrestrial hideouts. Think about it, the vast stretches of uninhabited land, coupled with the natural shielding provided by the mountains, create an almost impenetrable fortress. Stories and legends of unexplained phenomena in mountainous regions are as old as time itself. From the Himalayas to the Andes, people have reported sightings of strange lights, unidentified flying objects, and even encounters with beings not of this world. These accounts, often dismissed as folklore, hold a persistent place in the cultural tapestry of these regions, suggesting that there may be more to these mountains than meets the eye. Moreover, the mountain ranges are riddled with caves and underground passages, some of which have yet to be fully explored. These hidden crevices provide ample opportunity for extraterrestrial beings to establish concealed bases far from prying human eyes. The difficulty in accessing these areas means that any alien activity could remain undetected for centuries, if not longer. Interestingly, many of these mountain ranges are also hotspots for magnetic anomalies and unexplained electromagnetic activity. Instruments go haywire, compasses spin out of control, and electronic devices malfunction without apparent reason. Could these anomalies be indicative of extraterrestrial technology at work, subtly interfering with our own? Now let's shift our focus to the icy expanse of Antarctica, a continent shrouded in mystery and extreme conditions. With temperatures plummeting to as low as -90 degrees Celsius and winds that can reach up to 200 miles per hour, Antarctica is undoubtedly one of the most inhospitable places on Earth. Yet it is these very conditions that might make it an appealing hideout for extraterrestrial beings. The vast ice sheets and glaciers of Antarctica conceal what lies beneath, and recent discoveries have revealed lakes and even mountain ranges hidden under miles of ice. This hidden world, untouched by humans, provides a blank canvas for potential alien activity. The sheer isolation of Antarctica, combined with the extreme conditions, ensures that any bases or technology hidden beneath the ice would remain well protected and concealed. Moreover, there have been numerous reports and conspiracy theories surrounding UFO sightings and mysterious phenomena in Antarctica. Some have even suggested that the continent is home to ancient alien bases, buried beneath the ice for thousands of years. While there is no concrete evidence to support these claims, the allure of Antarctica's icy desolation makes it a compelling candidate for extraterrestrial activity. Intriguingly, Antarctica is also a place of scientific anomalies, with researchers recording unexplained changes in gravity, bizarre weather patterns, and mysterious sounds emanating from the ice. These phenomena have puzzled scientists for years and have led some to speculate about potential alien involvement. So, as we ponder the question of where extraterrestrial beings could be hiding on our planet, we find that from the seclusion of the mountains to the frozen fortress of Antarctica, our world is filled with enigmatic landscapes that could potentially harbor alien life. These remote and inaccessible places challenge us to look beyond the obvious and consider the possibilities of what might be hiding just out of sight. Have you ever gazed at the night sky and wondered if there's intelligent life out there? And if there is, wouldn't it be absolutely fantastic to meet them, perhaps for an intergalactic coffee or just some good old cosmic banter? Well, not so fast. Today we're diving deep into the theories and ideas of why meeting extraterrestrial life might not be the best thing for us. The vastness of our universe is truly mind-boggling. With billions upon billions of stars, many of which have their own planetary systems, the question arises, where is everyone? Why haven't we found signs of intelligent life? Or why haven't they found us? This puzzling conundrum, sometimes referred to as the Fermi paradox, poses the question, if the universe is so big, shouldn't there be evidence of intelligent life out there? Enter the Great Filter Theory. This theory offers a possible solution to the Fermi paradox. It suggests that there's a stage or multiple stages in the evolutionary process of life that act as a sort of bottleneck, preventing species from further advancing or even causing them to go extinct. Imagine the path to cosmic intelligence as a series of steps. These steps could include the formation of planets, the emergence of simple life, then complex life, the development of intelligence, and eventually the creation of technology capable of cosmic communication or travel. If every one of these steps was easy and inevitable, our universe should be teeming with life. However, the Great Filter Theory posits that one of these steps, or perhaps more than one, is incredibly improbable. It's a filter that prevents most potential life from advancing to the next stage. Now, this theory can be both comforting and unsettling. If the Great Filter is behind us, perhaps in the leap from non-life to life or from simple to complex organisms, then we might be one of the few, if not the only, civilizations that made it through. That would mean the universe is ours to explore with little worry about encountering advanced alien civilizations. On the other hand, if the Great Filter lies ahead of us, it means our civilization is headed towards some insurmountable challenge. This could be anything from self-destruction via war, catastrophic environmental collapse, or any other number of unforeseen challenges that have doomed other civilizations before us. In the realm of interstellar interactions, a fascinating concept emerges, one that reflects past human histories, the dependency paradox. When two civilizations of vastly different technological levels meet, there's a chance that the less advanced society becomes heavily reliant on the superior technology of the more advanced civilization. Drawing parallels from our own history, when indigenous communities encountered technologically advanced colonizers, they were often introduced to new tools, weapons, and methods that, while advantageous, led to a dependency. Traditional skills and techniques passed down through generations were quickly abandoned in favor of the new technology. But this shift came at a cost. These societies became vulnerable, losing autonomy and self-sufficiency. Now let's elevate this scenario to a cosmic scale. If humans were to depend heavily on alien technology, we might experience a profound societal change. The rapid introduction of such superior tech might lead to the abandonment of our own innovative pursuits. Why invent or innovate when technology from a more advanced civilization is readily available? Furthermore, with dependency comes vulnerability. If for any reason the advanced civilization withdraws or restricts access to their technology, the less advanced society, in this case us, might find itself in a precarious situation. Societies, infrastructures, and systems built upon and adapted to the alien technology might collapse or malfunction without it. Additionally, such a dependency could have profound psychological effects. The sense of inferiority, the loss of self-reliance, and the overshadowing of human achievements by alien wonders might lead to a collective identity crisis. Who are we in a universe where our accomplishments seem trivial compared to those of extraterrestrial beings? The universe, vast and teeming with endless possibilities, may harbor civilizations that, should they ever cross our path, might have intentions that are difficult for us to fathom. The intentions of an alien species, especially one that can traverse galaxies and has advanced far beyond our comprehension, are a pressing concern in any potential first contact scenario. When we reflect upon our own history, encounters between societies of differing technological levels rarely ended favorably for the less advanced culture. Often, such meetings were characterized by conquest, resource extraction, or unintentional harm, such as the spread of diseases. If our history is any lesson, it's that the balance of power and intent plays a significant role in the outcomes of first contacts. Now think about a civilization advanced enough to reach our planet from the distant corners of the cosmos. The sheer technological prowess required for interstellar travel would indicate capabilities beyond our understanding. But technology alone doesn't dictate intentions. While it's hopeful to imagine that any society which has achieved such advancements would have also evolved beyond aggression or territorial conquests, we cannot be certain. A civilization might seek resources unique to our world, be it water, minerals, or even something as abstract as information. They might see Earth as a suitable colony, or perhaps a strategic vantage point in a larger cosmic plan. On the more benign side, their intentions could be purely scientific. To them, we might be a curious case study, a species to be observed and documented, much like how we study less developed species on Earth. But even benign intentions can have unintended consequences. An alien civilization might not understand the intricacies and fragilities of our ecosystems, societies, and individuals. It's also worth considering the scenario where they might be escaping some cosmic calamity, or are refugees searching for a new home. In such a case, their desperate situation could make interactions unpredictable. Lastly, their moral and ethical constructs might be entirely different from ours. Concepts of right and wrong, shaped by their unique evolutionary history and societal growth, could vary greatly from human norms. What they might see as an act of kindness or necessity, we might perceive as an act of aggression or vice versa. Thus, the crux of the matter is not just the discovery of extraterrestrial life, but understanding and navigating their intentions, hoping that mutual respect and universal codes of ethics guide our interactions. Imagine for a moment two worlds colliding, not in the astronomical sense, but on the microscopic front. The alien life we imagine often involves technologically advanced beings or massive spaceships, but rarely do we contemplate the minute, unseen life forms they might carry, their microbial companions. Throughout human history, the spread of diseases has profoundly influenced civilizations. When travelers from different continents met, they didn't just exchange cultural and technological ideas. They also unknowingly shared viruses and bacteria. These unintended exchanges led to outbreaks like smallpox in the Americas after European arrival. The native populations, having never been exposed to such diseases, had no immunity. The results were often catastrophic. Now extrapolate this to a galactic scale. Meeting alien life forms might introduce us to entirely new biological systems. These extraterrestrial organisms, whether harmful in their native environment or not, could have unpredictable effects on Earth's biosphere. It's not just about potential pathogens harming us. Humans might have reactions to alien life at the fundamental cellular or molecular level. Proteins, enzymes, or even chemical compounds foreign to our biology might trigger unforeseen responses in our bodies. Conversely, human microbes might pose a threat to them. What's benign to us might be deadly for them. This inter-exchange of biological material might lead to a scenario where both parties unintentionally harm each other despite peaceful intentions. Moreover, these alien microbes, if they find Earth's environment hospitable, might become invasive species. They could outcompete, prey on, or bring diseases to native species, causing ecological imbalances. We've seen the profound effects of introducing non-native species to new ecosystems on Earth. Alien organisms with no natural predators or controls here could proliferate uncontrollably. There's also the aspect of our planet's environment. If these microbes play a role in their planet's atmospheric balance or any other critical environmental process, their introduction to Earth might have large-scale effects on our climate, weather patterns, or even the composition of our atmosphere. Throughout history, different cultures on Earth have experienced dramatic upheavals when encountering another society with vastly different beliefs, technologies, or ways of life. We can look back at instances of first contact between indigenous peoples and technologically advanced explorers as a small-scale model of what could happen on a galactic scale. These meetings have often resulted in misunderstandings, unintended consequences, and even the unintended destruction of one of the cultures. Now let's magnify this scenario to the interstellar scale. Imagine the vast differences that might exist between our human society and an alien civilization that has evolved independently, possibly for millions or even billions of years. The differences in our communication methods, perceptions, emotions, societal norms, and priorities might be insurmountably vast. The sheer act of comprehending and understanding their intentions, philosophies, and technology could be overwhelming, leading to profound cultural shock. We are creatures of habit, shaped by our evolutionary lineage, environmental pressures, and societal structures. Confronting beings who might not share any of these evolutionary or societal histories with us could challenge the very core of our understanding and beliefs. Moreover, their technological advancements could make our most cutting-edge tech look rudimentary in comparison. And just as the indigenous tribes of our world were awestruck and overwhelmed by the technology of explorers, humans might find themselves in a similar position, but on a cosmic scale. This vast difference in technology could lead to a power imbalance. Even if the alien civilization has peaceful intentions, their mere presence and advanced abilities could inadvertently disrupt our societal structures, economies, and technologies. Throughout history, the trajectory of human technological advancement has been somewhat linear. Societies grow, cultures build upon the knowledge of their predecessors, and over time new inventions and methodologies are birthed. This steady march of progress has been charted by historians, sociologists, and scientists alike. But every once in a while there's a hiccup in the timeline, a sudden, almost inexplicable burst of progress. Consider the rapid development of the integrated circuit or microchip. In the span of a few decades, we went from room-sized computers with the computing power of a modern calculator to pocket-sized devices that could access vast swathes of human knowledge. These leaps are fascinating, not only because of the technological marvels they produce, but because they often don't align with the expected progression. Now, to add a sprinkle of cosmic wonder to the mix, let's indulge in the speculative. What if some of these rapid advancements didn't have their origins in human thought? What if, hidden among our countless innovations, some were inspired, tweaked, or even directly acquired from extraterrestrial sources? It's an alluring thought, especially when we consider the pace at which some of these technologies have emerged and the transformative impact they've had on society. One might argue that human collaboration, the globalization of information, and cumulative innovation could explain these jumps, and they'd be right for the most part. But isn't there a sliver of wonder, a tiny what-if that might suggest otherwise? After all, in the vast expanse of the universe with its billion of stars and potentially even more planets, could it be possible that we've had a little nudge along the way? Even if this speculation remains firmly in the realm of fiction, the very act of questioning, of wondering, propels us forward. It challenges us to look beyond the familiar horizon and entertain the infinite possibilities that lie beyond. And whether those possibilities are of our making or inspired by something or someone beyond the stars remains one of the greatest mysteries of our time. Human history is punctuated with moments of technological marvels that seem, at first glance, to come out of nowhere. These sudden advances, which defy linear progression, often raise eyebrows and fuel theories about extraterrestrial influences. One particularly enticing area of investigation is the realm of advanced propulsion systems and the anomalous technologies that accompany them. Let's start with the basics: propulsion. Our understanding of propulsion has, for the longest time, been based on Newton's third law. Every action has an equal and opposite reaction. This is the principle that governs everything from the combustion engines in our cars to the colossal rocket engines that send astronauts into space. But in the last few decades, there have been whispers and leaked reports of propulsion systems that don't adhere to this conventional wisdom. The idea of reactionless drives or propulsion systems that function without emitting any tangible exhaust has been a subject of both ridicule and intrigue in the scientific community. Now, onto the anomalies. Over the years, there have been multiple reports, some more credible than others, about materials and technologies that seem to defy the laws of physics. Memory metals, substances that revert to a predefined shape, irrespective of how they've been manipulated, are one such example. These materials, light, flexible, and incredibly resilient, don't align neatly with our current understanding of metallurgy or material science. Then there's the topic of energy sources. Contemporary human technology is primarily powered by electricity, derived from various sources like fossil fuels, nuclear power, and renewables. However, there have been persistent rumors about devices often linked to unidentified aerial phenomena, powered by energy sources unknown to modern science. These energy sources, seemingly compact, incredibly efficient, and with emissions profiles that are negligible, are a dream for current technological applications. If there's any truth to these speculations, the implications of such an energy source would be revolutionary. Piecing it all together, one could argue that these tech anomalies and whispers of advanced propulsion systems point to a potential outside influence, perhaps extraterrestrial in nature. But without concrete evidence, these remain in the realm of speculation and conjecture. The search for answers continues, but in the meantime, these mysteries offer a tantalizing glimpse into what might be possible, urging us to push the boundaries of our understanding and reach for the stars, both metaphorically and literally. Metamaterials have captured the imagination of researchers and enthusiasts alike, representing a class of materials that exhibit properties not found in naturally occurring substances. What makes metamaterials so fascinating is their unique, almost otherworldly ability to manipulate electromagnetic waves in ways that traditional materials can't. From invisibility cloaks to superlenses that surpass the limitations of conventional optics, the potential applications of these materials seem to border on science fiction. Delving deeper into their structure, metamaterials aren't derived from exotic elements sourced from distant galaxies. Instead, they owe their unique properties to their intricately engineered microstructures. These microstructures, often smaller than the wavelength of light they interact with, give metamaterials their power. By controlling and designing these structures at a microscopic scale, scientists can manipulate how these materials interact with light, radio waves, and other forms of electromagnetic radiation. The talk of advanced alloys, on the other hand, brings us to a slightly different territory. Alloys, as we understand them, are combinations of metals designed to imbue certain desirable properties. From the bronze of our ancient ancestors to the high-strength steels and superalloys of today, humanity's progress has been marked by our ability to create and harness the properties of alloys. But what if there exist alloys beyond our current comprehension, materials with attributes so unique that they challenge our current scientific understanding? There have been murmurs, especially in the circles focused on unidentified aerial phenomena, about the discovery of unknown alloys. These materials, often associated with unexplained crash sites or encounters, purportedly exhibit properties that cannot be accounted for based on our existing metallurgical knowledge. Whether it's resistance to extreme temperatures, inexplicable lightness combined with strength, or other unique electromagnetic interactions, these alloys represent another piece in the puzzle of potential extraterrestrial technology. While the origins and full capabilities of metamaterials and advanced alloys remain a topic of investigation, their very existence pushes us to question the limits of our technological understanding. It nudges us toward a future where the line between the natural and the engineered, the understood and the mysterious, becomes increasingly blurred, propelling us forward in our quest for knowledge and innovation. In the annals of modern ufology, few events have captured the public's imagination and stoked as much debate as the Roswell incident of 1947. A seemingly unassuming town in New Mexico became the epicenter of an event that would fuel discussions, investigations, and speculations for decades to come. But what really happened at Roswell? And more importantly, did it have a lasting impact on our technological development? The official narrative is well known. A rancher stumbled upon debris on his property which the US military initially described as a flying disc, before retracting that statement, declaring it the remnants of a weather balloon. Case closed, right? However, the inconsistencies and rapid backtracking in the official narrative only further fueled speculations. Soon, stories began circulating about not just debris, but an actual crashed spacecraft and even extraterrestrial bodies being recovered from the site. But let's dive a bit deeper into the implications of the Roswell incident in the context of technology. There's a theory, albeit largely in the domain of speculative fiction, that suggests some of the materials or technology retrieved from the Roswell site made their way into research labs. These labs, covert and dedicated to reverse engineering, aim to understand, replicate, and perhaps even implement alien technologies into human-made devices. Consider the growth and emergence of stealth technology, advanced propulsion systems, and even the aforementioned integrated circuits. Could it be mere coincidence that these technologies began to gain significant traction after the 1940s? While there's no concrete evidence linking the Roswell incident to these technological advancements, the timing is at the very least intriguing. Furthermore, witness testimonies, although often discredited or brushed aside, have hinted at the potential for technologies beyond our understanding present at Roswell. Whispers of materials that could change shape and composition, or propulsion systems that defied our understanding of physics, continue to circulate. The James Webb Space Telescope is often heralded as the successor to the Hubble Space Telescope, but in reality, its capabilities go far beyond its predecessors. Set to redefine our understanding of the universe, the JWST's conception and the technology that drives it are nothing short of groundbreaking. Designed with the primary mirror spanning 6.5 meters, more than 2.5 times the diameter of Hubble's, the JWST promises unprecedented resolution and sensitivity. However, it's not just the size of the mirror that sets this telescope apart, it's the engineering behind it. Composed of 18 hexagonal segments coated with a thin layer of gold to optimize infrared reflection, these mirrors can be adjusted individually, allowing for in-flight calibrations. This design ensures optimal imaging performance, even after the wear and tear of a launch and deep space operations. The telescope's position is another intriguing aspect. Instead of orbiting Earth like Hubble, the James Webb Space Telescope is set to occupy a location known as the second Lagrange point, or L2, nearly 1.5 million kilometers away from our planet. At this spot, the gravitational forces between the Earth and the Sun, as well as the orbital motion of the telescope, all balance out, allowing the telescope to effectively hover in a stable position relative to the Earth and Sun. This unique position affords it an unobstructed view of the universe, free from the interference of Earth's atmosphere or thermal emissions. One of the driving goals behind the telescope is its quest to capture light from the first galaxies that formed after the Big Bang. By focusing on infrared observations, it can look further back in time than ever before, studying the formation and growth of these ancient galaxies and providing insights into the early phases of the universe. But its infrared prowess doesn't stop there. It's also ideally suited to study the formation of stars and planetary systems, including those in our own Milky Way galaxy. The technologies behind the James Webb Space Telescope raise questions about their origins. Given the massive leap in technological capabilities and the precision engineering required for its instruments, one might wonder, could any of its technological inspirations have roots in knowledge beyond our planet? While there's no direct evidence to suggest extraterrestrial influence, the mere existence of such advanced instruments sparks curiosity and opens the door to endless possibilities about our universe and the technologies we devise to study it. Embarking on a journey through the cosmos, we find ourselves entangled in one of the most profound mysteries of modern astrophysics, dark matter. This elusive substance, invisible to our current observational instruments, is believed to constitute approximately 27% of the universe's mass and energy. Unlike normal matter, which makes up stars, planets, and even us, dark matter does not emit, absorb, or reflect light, rendering it virtually undetectable through direct observation. The concept of dark matter was born out of an astronomical conundrum. In the 1930s, the Swiss astrophysicist Fritz Zwicky observed that galaxies in clusters were moving much faster than they should be, based on the gravitational pull of their observable mass alone. This discrepancy suggested the presence of some unseen mass exerting an additional gravitational force, what Zwicky referred to as Dunkel Materie, or dark matter. Further evidence for dark matter emerged from observations of galaxy rotations. According to the laws of physics, the speed at which stars orbit the center of their galaxy should decrease with distance. However, when astronomers observed galaxies, they found that stars on the outskirts were orbiting just as fast as those near the center, a phenomenon that defied explanation unless there was additional unseen mass in the galaxies. This invisible mass seemed to form a halo around galaxies, influencing their dynamics and structure. Another intriguing aspect of dark matter comes from the phenomenon of gravitational lensing, the bending of light from distant objects by massive foreground galaxies. The degree of bending observed in these cases indicates far more mass than can be accounted for by visible matter alone. In essence, dark matter acts as a cosmic magnifying glass, altering the path of light through the universe. The precise nature of dark matter, however, remains a tantalizing mystery. The leading hypothesis is that it is composed of weakly interacting massive particles, which barely interact with regular matter. Other theories propose candidates like axions or sterile neutrinos, particles that are fundamentally different from those found in the standard model of particle physics. The pursuit of dark matter has also led to the development of highly sensitive detectors buried deep underground or submerged in water or ice. These facilities aim to shield experiments from cosmic rays and other forms of interference that could mimic the elusive signals of dark matter particles. The notion that dark matter could serve as a conduit for extraterrestrial communication is a thought-provoking intersection of astrophysics and the search for intelligent life. This theory springs from the idea that an advanced alien civilization, far beyond our current technological capabilities, might utilize the properties of dark matter to communicate across the vast expanses of space. But why dark matter? The answer lies in its ubiquitous presence and its unique, enigmatic properties. Dark matter, by its very nature, does not interact with electromagnetic radiation, the cornerstone of human methods of communication such as radio waves. This means that messages encoded in dark matter wouldn't suffer the same fate as electromagnetic signals, which dissipate and lose their strength over interstellar distances. Furthermore, dark matter isn't hindered by cosmic dust or other interstellar matter that can absorb or scatter electromagnetic radiation. Hence, it stands as a potentially more efficient medium for long-distance communication in the cosmos. The challenge, however, lies in the theoretical framework and technological advancements required to harness dark matter for communication. If dark matter is composed of WIMPs, these particles might interact with regular matter through gravity or weak nuclear forces. An advanced alien civilization could theoretically manipulate these interactions to encode information. This process would be akin to modulating a carrier wave in radio communication, but on a far more subtle and complex level. Moreover, the potential of dark matter communication opens up new realms in our understanding of the Fermi paradox. The apparent contradiction between the lack of evidence for extraterrestrial civilizations and various probability estimates for their existence. It's conceivable that alien civilizations are using dark matter to communicate, and humanity's current technological limitations prevent us from intercepting or understanding these communications. Our focus on electromagnetic signals may be the equivalent of listening for a whisper in a world where other civilizations are using a different form of sound altogether. Another fascinating aspect to consider is the stability of dark matter signals. Unlike electromagnetic signals, which can be altered or disrupted by various cosmic events, dark matter remains largely unaffected by the universe's dynamism. This stability could make it an ideal medium for not just communication, but also for storing information over cosmic timescales. However, the use of dark matter for communication remains purely speculative, as our understanding of dark matter is still in its infancy. Our current experiments and observations are geared toward detecting dark matter and understanding its properties, rather than manipulating it for communication. Delving into the cosmos's enigmatic corners, we encounter a fascinating and speculative idea. Could life forms exist that are composed of dark matter? This notion challenges the very foundation of our understanding of life and its necessary conditions. The concept of dark matter life stems from the fact that dark matter, which makes up a significant portion of the universe's mass, interacts with gravity but remains virtually undetectable in other ways. This invisible and enigmatic nature of dark matter raises the question, could there be entities, perhaps even entire ecosystems, that are based on dark matter instead of the baryonic matter that constitutes the known life on Earth? To explore this idea, let's first consider what we understand about life. On Earth, life is carbon-based, relying on water and a complex chemistry involving a handful of elements like carbon, hydrogen, oxygen, and nitrogen. However, the universe is vast and diverse, and the possibility that life could develop based on entirely different principles cannot be entirely dismissed. If dark matter life exists, it would likely be radically different from anything we know. These hypothetical beings would not interact with light, making them invisible and intangible to us. They could be living right beside us, yet completely undetectable with our current technology and methods. The intriguing part about dark matter life is how it might interact with its environment. Since dark matter does not interact electromagnetically, the conventional notion of biology, involving absorption of light for energy or chemical reactions, would not apply. These life forms, if they exist, would have to rely on an entirely different set of principles for their metabolic processes. They might utilize weak interactions or gravitational effects to sustain themselves. This raises fascinating questions about their structure, reproduction, evolution, and even consciousness. Astrophysicists and biologists have pondered over this, and some theories suggest that dark matter organisms could exist in a parallel realm, only interacting with our world through gravity. These interactions could potentially explain some of the unaccounted gravitational anomalies observed in the universe. Moreover, the concept of dark matter life forms extends beyond the realm of biology into the realm of astrobiology and the search for extraterrestrial intelligence, SETI. If life can exist in a dark matter form, it broadens the scope of SETI to look beyond traditional signals like radio waves or visible light. Perhaps these life forms have developed their own means of communication and society, which we are yet to comprehend or detect. The pursuit of dark matter has propelled scientists into a new era of technological innovation, as they endeavor to detect something that neither emits nor absorbs light and has eluded direct observation. This quest has given rise to an array of sophisticated experiments and detectors, each designed to catch a glimpse of this mysterious substance that is believed to permeate the universe. One of the forefront technologies in this pursuit is the use of underground laboratories. These facilities, like the large underground xenon experiment in South Dakota and the Gran Sasso National Laboratory in Italy, are located deep beneath the Earth's surface. The depth is crucial, as it shields the experiments from cosmic rays and other forms of background radiation that could interfere with the detection of dark matter particles. Inside these labs, detectors are immersed in fluids like xenon or argon and maintained at incredibly low temperatures. The hope is that as dark matter particles pass through these detectors, they will collide with the nuclei of the atoms in the fluid, producing a flash of light or an electrical signal that can be measured. Another promising technology is the use of space-based detectors. Unlike ground-based observatories, these instruments can search for evidence of dark matter particles from orbit, free from the Earth's atmospheric interference. The Alpha Magnetic Spectrometer, also known as AMS, installed on the International Space Station, is one such detector. It searches for indirect evidence of dark matter, such as the presence of specific particles that could be byproducts of dark matter collisions or decay. In addition to these experimental setups, advancements in particle accelerators have also played a significant role. The Large Hadron Collider at CERN, the world's largest and most powerful particle accelerator, has been conducting experiments that could provide insights into the properties of dark matter. By colliding particles at high energies, scientists hope to create conditions that could briefly produce dark matter particles, allowing us to study their properties and interactions. One of the intriguing aspects of these experiments is the search for weakly interacting massive particles. WIMPs are a leading candidate for dark matter, as they would only interact weakly with ordinary matter, explaining why they have been so difficult to detect. However, despite years of searching, WIMPs have remained elusive, leading some scientists to consider alternative candidates, such as axions or sterile neutrinos. The technology used in these searches must be incredibly sensitive, as the interactions between dark matter particles and baryonic matter are expected to be rare and subtle. This sensitivity makes the experiments vulnerable to even the slightest environmental or instrumental noise, requiring innovative solutions to isolate the detectors from potential sources of interference. As we delve deeper into the cosmos, the role of dark matter becomes increasingly significant and fascinating. This mysterious substance, which does not emit, absorb, or reflect light, plays a crucial role in the grand cosmic ballet. Despite being invisible, dark matter exerts a gravitational pull, influencing the motion of galaxies and the structure of the universe at the largest scales. One of the most profound roles of dark matter is in the formation and evolution of galaxies. The current understanding among astronomers is that dark matter acts as a cosmic scaffolding around which galaxies are built. In the early universe, dark matter would have begun to clump together under its own gravity, forming a web-like structure. These dark matter concentrations created gravitational wells that attracted normal baryonic matter, leading to the formation of stars and galaxies. Without the presence of dark matter, the gas in the early universe would not have had enough gravitational pull to coalesce and form these structures. Dark matter also plays a pivotal role in holding galaxies together. When astronomers observe the rotation of galaxies, they find that the stars at the edges of galaxies are moving just as fast as those near the center, contrary to what would be expected if only visible matter were present. This observation suggests that something unseen, dark matter, is providing additional gravitational force binding the galaxies. Without dark matter, galaxies like our own Milky Way might not have been able to maintain their present form and could have been torn apart by their own rotational speed. Furthermore, dark matter is essential in understanding the overall structure and fate of the universe. It is a key component in the Lambda CDM model, the standard model of cosmology that describes the universe as composed of dark energy, dark matter, and normal matter. The interactions and relative proportions of these components determine the rate of expansion of the universe and its ultimate fate. Dark matter's gravitational pull works against the repulsive force of dark energy, which is accelerating the expansion of the universe. This interplay is a critical factor in cosmological models that predict how the universe will evolve over billions of years. The study of dark matter also intersects with other areas of astrophysics, such as the study of gravitational lensing. This phenomenon, where light from distant galaxies is bent around massive objects, provides indirect evidence of dark matter. The amount of lensing observed in these instances is far greater than what would be expected based on visible matter alone, reinforcing the theory that dark matter is present and abundant in the universe. In cosmic voids, large, empty spaces in the universe where few galaxies exist, dark matter plays a subtle yet important role. These voids are not entirely devoid of matter but contain small amounts of dark matter, influencing the motion and distribution of galaxies at the edges of these voids. The idea that Earth could be a cosmic prison is not merely science fiction. It's a hypothesis that tickles the edges of philosophy, ethics, and our understanding of advanced civilizations. To fully appreciate this concept, we must question our place in the universe and examine our nature and limitations. Imagine a universe filled with civilizations so advanced that they have not only mastered space travel, but also ethical dilemmas and social structures on a cosmic scale. These civilizations could conceivably create a prison for those deemed dangerous or undesirable. Earth, in this context, could be one such prison. What would make Earth a perfect prison? Its isolation in space, the limitations of human biology, and the barriers to interstellar travel could all be carefully engineered constraints. Our environment sustains us, but also contains us. Diseases, natural disasters, and the vastness of space could all be mechanisms that keep us in check. The imprisonment might not just be physical. Limitations on our intellectual growth and spiritual understanding could also be part of this cosmic incarceration. This aspect of the theory suggests that our understanding of the universe is intentionally limited, keeping us from uncovering the true nature of our existence. Understanding why humans might be imprisoned requires a philosophical leap. Were we once part of an advanced civilization that fell from grace? Are we being quarantined for the protection of other beings? Or perhaps we are an experiment observed for some unknown purpose. Subtle hints or artifacts could be hidden within our planet or even within our DNA, waiting to be discovered. These might be clues left by our cosmic jailers, messages or warnings to guide or control our development. The concept of the panopticon was first brought to light by the philosopher Jeremy Bentham in the late 18th century. A panopticon is a circular prison where inmates are under constant surveillance from a central watchtower, yet they can't see when they are being watched. This unique design was intended to control behavior through the fear of constant observation. Applying this idea to the entire universe, or our place in it, offers an intriguing lens through which to explore the notion of Earth as an alien prison. If Earth were a prison, the panopticon model suggests that there might be constant surveillance from a cosmic standpoint. Unlike a physical watchtower, this cosmic panopticon might employ advanced technologies or even metaphysical mechanisms that we can't comprehend. The watchful eyes of a higher civilization could be monitoring our every move, every thought, even our spiritual evolution. The most potent effect of a panopticon is the psychological control it exerts. Inmates, unsure of when they are being watched, regulate their own behavior as though they are always under observation. If we extrapolate this concept to a cosmic level, it could mean that our very thoughts, behaviors, and cultural development are being shaped or limited by unseen observers. The mysteries of human consciousness and our search for meaning might be influenced by this invisible presence. A panopticon on a cosmic scale could imply not only psychological but technological control. Limitations on our scientific advancements could be deliberately engineered to keep us confined to Earth. Every time humanity approaches a breakthrough that might lead to interstellar travel or deeper understanding of the universe, unseen forces could subtly guide us away or create barriers to our progress. Who would be the watchers in this cosmic panopticon? Are they gods, aliens, or something beyond our understanding? Are they benevolent, guiding us toward enlightenment at a pace we can handle? Or are they malevolent, suppressing us for reasons we can't fathom? Subtle clues to the existence of a cosmic panopticon might exist in ancient texts, mysterious phenomena, or even within our own psychology. The universal religious themes of omniscient deities, spiritual tests, and cosmic judgment may not be mere products of human imagination, but echoes of a grander truth. As we look at the history of human civilization, we can see an astounding progression of technological and social achievements. However, it's also possible to identify certain constraints or barriers that seem to hinder our advancement. Could these limitations be part of a designed system to contain humanity within a specific framework? In exploring the Earth as a prison hypothesis, we must examine these constraints and consider whether they may be deliberate manipulations by an external force. From fire to the wheel, from steam power to quantum computing, our technological advancements have been rapid and significant. Yet there remain specific challenges and barriers that seem to elude us. The lack of significant progress in areas like fusion energy, faster-than-light travel, or even fully understanding our own brains raises questions. Are we hitting our natural limits, or is there a force preventing us from making these groundbreaking discoveries? Historically, we've seen the rise and fall of empires, revolutions, and reforms, yet many of the fundamental structures and inequalities persist. Despite our advancements in philosophy, politics, and social sciences, we continue to grapple with recurring issues like poverty, war, and injustice. Could these recurring patterns be engineered to maintain a status quo, keeping us occupied with earthly matters and preventing us from looking beyond our planet? Our dependence on Earth's natural resources binds us to this planet. We rely on fossil fuels, minerals, water, and the delicate balance of our ecosystem. Even our most advanced space technologies are limited by these earthly dependencies. Is this a natural result of evolution, or could it be a designed constraint to keep us tethered to Earth? Our own minds might be our greatest constraint. Fear of the unknown, skepticism towards new ideas, conflicts between science and faith. All these psychological factors can limit our pursuit of knowledge and understanding. This mental confinement might be a deliberate aspect of our supposed prison, ensuring we don't break free from our established paradigms. If these constraints are indeed part of a grand design, who or what is responsible? Alien overseers with advanced technologies could subtly manipulate our progress. Alternatively, cosmic laws or forces beyond our understanding might naturally enforce these limitations. The idea that Earth might be a prison for humanity isn't a purely modern concept. Throughout history, various myths, legends, and religious texts have alluded to ideas that resonate with this hypothesis. These ancient narratives, spread across different cultures and epochs, might hold hidden clues that lend credence to the theory that our world is a containment facility overseen by otherworldly beings. In ancient Sumerian texts, the Anunnaki were a group of deities who were said to have created and controlled humanity. Some interpretations of these texts suggest that the Anunnaki might have used humans for labor, creating a system that restricted human freedom and kept them confined to specific roles and locations. Greek mythology tells the tale of Prometheus, who stole fire from the gods to give to humanity. His punishment, being chained to a rock, could be seen as a symbolic representation of humanity's confinement to Earth, restricted by greater cosmic forces. In Hindu mythology, Lord Shiva performs the cosmic dance that controls the universe's destruction and creation. This cyclical nature of existence, where destruction leads to rebirth, might symbolize the perpetual constraints that keep humanity confined within specific bounds, unable to escape a predefined cycle. Many Native American tribes speak of Spider-Woman who wove the web of existence. This web could be seen as a metaphor for the interconnected but restricted reality that humans find themselves in, with the strands representing the unseen barriers that keep us in place. Even in contemporary times, stories of UFO sightings and alien abductions often contain themes of control, manipulation, and containment. These modern myths might reflect a subconscious awareness of our confinement, expressed through the lens of science fiction and popular culture. The recurring theme of confinement, control, and restriction across various myths and legends worldwide might be more than mere coincidence. These stories could be echoes of a profound truth hidden in our collective unconscious, pointing towards our existence within a controlled and confined space. The Fermi paradox presents one of the most intriguing questions in the field of astrobiology. With an estimated 100 billion galaxies in the observable universe, each containing billions of stars and even more planets, why haven't we detected any signs of extraterrestrial intelligence? Could this apparent silence in the cosmos be related to the idea that Earth is an alien prison, and if so, how? One explanation for this paradox is the concept of the Great Filter, a hypothetical barrier that prevents civilizations from reaching a certain level of technological advancement. Could this barrier be part of a containment strategy to isolate intelligent species, including humans, from each other? Another intriguing explanation is the zoo hypothesis, suggesting that extraterrestrial civilizations are deliberately avoiding contact with us. This could align with the Earth as a prison theory, where alien overseers maintain our isolation to prevent us from interfering with other parts of the cosmic prison system. The possibility that advanced civilizations inevitably self-destruct before reaching a level of technological maturity to explore the cosmos is a somber explanation for the Fermi paradox. If Earth is a prison, this self-destruction could be a designed outcome, ensuring that inmates never advance enough to escape or pose a threat. Our inability to detect extraterrestrial signals might also be a matter of technology. If alien civilizations use advanced communication methods beyond our comprehension, we wouldn't be able to detect them. In the context of the prison hypothesis, this could be a security measure to keep the communication of the jailers beyond the understanding of the prisoners. Some proponents of the Earth as a prison theory take the argument a step further by suggesting that the entire observable universe is designed in such a way to make us believe we are alone. This crafted illusion could be part of a complex containment strategy, reinforcing our isolation. What if the next frontier for imprisonment wasn't just a maximum security facility somewhere in the remote mountains, but far beyond our Earth, in the vastness of space? Today we are delving into, what if humans made a secret prison in space? We'll explore the utopian society that could necessitate it, the practicality of human versus cryogenic incarceration, and ponder over the eternal debate. Should this high-security fortress in the cosmos be manned by human guards or be completely automated? So what do we mean by a utopian society? In this hypothetical future, we've seen extraordinary advances in science, education, and technology that create a positive feedback loop with societal structures. People are more educated, which leads to better decision-making and a stronger social fabric. That, in turn, reduces crime because an educated populace tends to be a more ethical populace. Crime is basically a social construct, right? It emerges in contexts where there are significant disparities in resources, education, or social justice. Address these core issues, and crime rates plummet. Imagine technology so advanced that it could intervene before a crime happens. Not in a creepy surveillance state way, but more in the vein of identifying societal stressors and neutralizing them. Perhaps emotional and mental well-being could be so well understood that preemptive care becomes the norm. The utopian society of this scenario doesn't just throw money and tech at problems. It's also philosophically and ethically advanced. The value systems, moral codes, and even religions have likely evolved to be more inclusive, more forgiving, and less dogmatic. This is a society that understands the complexities of human behavior and deals with them in a sophisticated manner. But here's where things get a bit paradoxical. If you've managed to cultivate such a perfectly trust-based society, the very existence of a prison system would disrupt that trust, even if there is only a minuscule percentage of people who commit crimes. The notion that there is a place where people are forcibly confined could cast a shadow over the utopian dream. So what's the solution? Perhaps the answer lies not on Earth, but beyond it, and that's where the idea of a secret space prison comes in, but more on that later. The utopia hypothesis challenges us to consider how far we are willing to go to achieve a perfect society, and what sacrifices, ethical or otherwise, we are prepared to make. It also prompts us to think critically about whether a utopian society is even attainable, or whether it's a no place, an ideal that can guide us but never be fully realized. Fascinating, isn't it? But let's not stop there. What happens to those who simply don't fit into this idyllic world? Let's find out. All right, let's dive right in. If we've hypothetically crafted this near-perfect society on Earth, one that has effectively eradicated most forms of crime and social discord, why would we even need a prison? Well, here's where things get particularly interesting. Even in a utopian society, one of the great constants is human variability. Not everyone's neural circuits are wired the same way. And while most may adapt to a system of ethical and social norms, some might not. Think of it like a Gaussian distribution, or what you might recognize as a bell curve. In any large population, there will be outliers, individuals who, for a myriad of reasons, do not conform to societal norms. What do we do with these outliers in a society that is fundamentally based on trust and ethical consistency? Sending them to a conventional prison on Earth could challenge the foundational ideas of the utopia. It introduces an element of coercion and force that is contradictory to the society's principles. The very idea that you could be imprisoned could create an underlying tension, a ripple in the calm waters of the utopian dream. So, why not take the prison out of the equation, or rather, out of Earth's gravitational pull? Welcome to the concept of a space prison. By placing the prison in space, you're removing the physicality of the problem from the Earth, and perhaps symbolically you're also keeping the purity of the utopian dream intact. In this scenario, Earth remains a sanctuary of enlightened human cooperation, while the inevitable outliers are placed far from its surface. Now, you might argue that launching people into space is, well, astronomically expensive. Yes, but in a society that has advanced to this level, it's possible that space travel has also been revolutionized. Maybe it's as routine as catching a flight from New York to London. Or maybe the resource allocation is so efficient that society can easily afford it. And let's talk about oversight. Who watches the watchmen? Especially when the watchmen are light years away, it's a complex ethical and logistical question. Would the space prison be entirely automated? Would it be governed by a subset of Earth's laws? Or would it have its own set of rules adapted for the unique situation? You see, the idea of a space prison isn't just about the how, but also the why. It's an exploration into the outer reaches of human ethics and governance. How do you balance justice and freedom? How do you reconcile the inevitable imperfections within a nearly perfect society? So you're probably wondering, would these space-bound individuals be kept frozen? Or would they be conscious? And who or what would manage such a prison? Well, let's get into that. Ah, yes, the age-old debate of the science fiction world has now, in our hypothetical scenario, become a pressing ethical and logistical question. Should the inmates of our space prison be awake, living out their sentences, or should they be frozen in a state of cryogenic suspension? It sounds like something out of a dystopian novel, but bear with me here. First, let's tackle the idea of human incarceration. Now, if we're sending humans to live in a prison in space, the cost of sustaining life becomes an important factor. We're talking about life support systems, food, water, and waste management. In the vacuum of space, every ounce of oxygen counts. Then there's the issue of mental health. Imagine being confined not just within walls, but within the limits of a spacecraft, far away from Earth. That's social isolation to an extreme level. Would our society, as advanced as it is, be okay with this form of psychological toll? And what about rebellion? If the prison were to have human guards, there's always the chance of a mutiny. Even automated systems could potentially be overridden. It's a risk factor that can't be completely eradicated, so long as the prisoners are conscious and capable of action. Now let's consider cryogenic incarceration. On the surface, it seems like an ideal solution. Freezing an individual in a state of suspended animation could significantly reduce the resource cost. No need for food, water, or even oxygen in the traditional sense. A fully automated system could monitor the inmates, reducing the need for human oversight. This would also eliminate the risk of rebellion or escape attempts, assuming, of course, that the cryogenic process is foolproof. However, freezing a human for an extended period brings its own set of ethical dilemmas. What if the technology fails and the person never wakes up? Is that ethical? Furthermore, what happens when they are eventually unfrozen? If our society has advanced, will they be able to reintegrate? Or will they be a person out of time, struggling to catch up with the world that has long since moved on without them? It also begs the question of the purpose of incarceration. Is it punitive, rehabilitative, or purely segregative? If it's punitive or rehabilitative, cryogenic freezing might not achieve that goal, as the individual is essentially paused rather than experiencing a sentence. Each option, human versus cryogenic incarceration, has its own set of pros and cons, both logistical and ethical. And this is where the concept of a space prison gets tangled in a web of moral and practical complexities. So now that we've considered why a space prison might be necessary and how it might function, who or what would be in charge of this off-world facility? Let's dig deeper into that. And now we arrive at an important fork in the road. Should this space prison of the future be manned by human guards, or should it be completely automated? It's a question that pulls at the boundaries between human intuition and machine efficiency. This is not just a logistical issue, but also one that touches on ethics, psychology, and even the philosophy of what constitutes justice and humane treatment. Let's begin with human guards. The first advantage is experience. Human guards can make judgment calls based on a wide range of emotional and environmental factors that current technology can't perceive. If a fight breaks out between inmates, or if someone appears to be in distress, a human guard can use intuition and situational awareness to make complex decisions. Plus, the human touch, as it were, might make incarceration a less dehumanizing experience, potentially aiding in the rehabilitation process. However, humans are fallible. They can be biased, they can make mistakes, and they themselves would be isolated from Earth, creating a potential risk for mental health issues. They also require all the life-sustaining resources we discussed earlier: food, water, oxygen, and so on. Plus, in the isolation and potential monotony of space, the temptation for corruption or negligence might increase. So what about complete automation? Imagine a prison overseen by an AI warden and maintained by robotic guards. These machines would not need life support, they wouldn't get tired, bored, or corrupt, and they could potentially manage resources more efficiently. With advances in machine learning, an AI could adapt to the needs of the prison, even predicting conflicts before they happen based on inmate behavior data. Sounds ideal? Well, not so fast. Automating a prison system takes the human element out of a very human-centric process: justice. Machines do not have a moral compass, and even the most advanced AI is not conscious and therefore cannot make ethical judgments. There's also the concern about malfunctions or hacking. Imagine a rogue agent taking control of the entire prison system and its robotic guards. The consequences could be disastrous. Another factor to consider is the justice system itself. An automated prison might streamline the sentencing process, possibly making it more rigid and less prone to human error or bias. But is justice that's 100% by the book always the most fair or ethical? In the balance between human and machine, the debate over who should oversee a space prison is as complex as it is fascinating. Each option opens a Pandora's box of logistical challenges and ethical quandaries. So, we've explored the idea of a space prison, considered why it might be necessary, how we might keep inmates either awake or frozen, and who might guard this high-tech Alcatraz in the sky. But now let's ask ourselves, could society accept the ethical burden of such a place? Stay tuned for more, and as always, thanks for watching.